of chapter 1, Inequalities. And we're going to look at only two types for now. 1.7, last section of chapter 1. Did I start that? Yes, I did. Linear and absolute value inequalities. Linear and absolute value inequalities. Of course, there is also something called compound inequality. So basically, you could say kind of three types. Let's start refreshing our memory on a linear. Let's say 46. 4x minus 3 divided by 6 plus 2 greater or equal to 2x minus 1 divided by 12. Okay. I see how many fractions here? I see 3, an invisible 1 in the denominator, so I see 3 fractions. And we need to find the least common denominator. 6, 1, and 12. Do we agree with 12? Okay. Because they're all fractions except this one, you could say that. I recommend write 12 over 1, this one times 12, and this one times 12 over 1. Why 12 over 1? Because I highly recommend, please, simplify before you multiply. 6 divided by 6, 12 divided by 6. 12 divided by 12, 12 divided by 12. And this turns into 24. Can anyone dictate, without distributing just yet, for everyone to see what happens here? So there is a 2, parentheses, what? Perfect. As long as you can see it, I'm happy. So then 24 greater than or equal to, these two go away, so this is 2x minus 1. So my point here is, please do not get scared by fractions. There is no need. You can always eliminate them, especially in equations or inequalities. Now I will distribute. I get 8x minus 6 plus 24 greater or equal to 2x minus 1. Please do not move terms around like we did with the equations. Do not move terms around from left to right and vice versa before you fully simplify or combine like terms. Clean this up on both sides. Please do that first. So then we have 8x plus 18 greater or equal to 2x minus 1. Only now you're free to move terms around. Move 2x here and move 18 here. 8x minus 2x is 6x, and then 18 minus 1, I move, it becomes negative 18 minus 1 is negative 19. What will be the final step here? However, we also have to present the solution in interval notation, or solutions. We'll divide by, yes, 6 is a positive number, so we do not switch the inequality symbol. And now let's read this. X is a number that is negative 19/6 or bigger. So this is, I don't care for units. I'm only showing what's happening here. From negative infinity to infinity, there is an equal symbol here, so we have to use a bracket. Or if you prefer, use a point, full point. It's up to you. That's where the solution is found, or solutions are found, actually. So negative 19/6 to the right. In interval notation, exactly what you see. Negative 19/6, comma, infinity. And this is the interval notation. Yes?
It's a closed circle because it's greater than or equal to.
Exactly. A bracket for greater than or equal to. Okay, so I think we should look at another. Or are we okay with this? Okay, we can, if you find something, please bring it to class then. Let's look at those. So these were linear. linear. This was the linear inequalities. Now, let's look at an example with compound inequality. Okay, here's an example. 54 on 203. This is on 203. Compound inequality. And that is -6 less than x minus 4 and less than or equal to 1. There is only one thing we need to do here. We just need to eliminate this somehow. See you on Monday. Bye. Okay? So that's all I need to take care of in this particular situation. So I need to get rid of that -4. How do I get rid of a -4? Not multiply. This is not multiply. It's added to x. Say it again. Add 4 to all three sides. When I add it here, I get -2. When I add it here, I get x. And when I add it here, I get 5. So we're adding 4 to all three sides to eliminate -4 inside. And this is the solution. You don't have to do anything. A parenthesis at -2 and a bracket at 5. I prefer writing in front x is a number found in that interval. You don't have to if you don't want to.
How do you decipher again when the bracket goes on the left or right side?
The equal symbol dictates that. The equal symbol, bracket. No equal symbol, parenthesis.
Okay.
Any questions? Any questions? Please, Kim.
For compound inequalities, do you have to write it on the number line thing?
No, I presented a number line so you can see how I come up with the interval notation.
Oh, okay.
But you're correct. You're correct. MATLAB may ask you to present the graph
Okay.
as well as this.
Okay.
So be careful. Okay, so let's discuss the last one, the last type, absolute value. Inequalities. Absolute value inequalities. I'm going to go back to a simple example, and then we'll work on more complicated situations. Here it is. Remember when we solved this equation maybe half an hour ago? What did we say? Correct. Very good. 7 or -7. Now I want to solve two different inequalities. I want to solve this one, and then I want to solve this one. So we solve the equation, the absolute value of x equals 7. Now we're trying to solve the absolute value of x is less than or equal to 7 or greater than or equal to 7. These are completely different. They cannot have the same solutions. Okay? So leave some space in here so we can come back and write a final answer, because I need to talk about each individually, and then we'll come back to write the final answer. So let's talk about the first one. If this one said, find numbers whose distance is 7, from 0 is 7, and I found two numbers, this one says, find numbers whose distance from 7 is 7 or less. It doesn't say exactly 7. It says 7 or less. So 7 units away from 0 or less than 7 units away from 0. So how do I, because remember, you cannot solve this. If we cannot change it into something simple that we can solve, we don't know how to solve it. We can't do anything. So here we only have to think. So I'm looking for numbers whose distance from 0 is 7 units or less. How do I translate this then? Where will I find those numbers? Between what and what? I'm showing. Between -7 and 7. Yep. Right? So two numbers are 7 units away from 0, 7 or -7, or less. So this is the translation. In interval notation, this will be just what you see. X in this interval. So therefore, the first one translates into this. And the interval notation follows. So on the real line then, we know that this is -7 and this is +7. And these two are solutions to the absolute value of x equals 7. Now in here are solutions to what? One more time. All these. Solutions to the absolute value of x less than or equal to 7. Awesome. And now remember, we still have a second possibility. What does this say? What does the absolute value of x greater than or equal to 7 tell us? So the first one was -7, 7, and in between. Now the last one says -7 or 7 and away, further away from 0 than 7 and -7. The first one says this, in between. The second one says this, which are two separate inequalities. They cannot be solved as a chain. So it means this side, and it means this side. So therefore, we will write two separate inequalities. X greater than or equal to 7, or I'm going to erase this, of course, x less than or equal to -7. That's what the second one means. Two separate inequalities. Okay? To the right-hand side of 7, which means x greater than or equal to 7, or to the left-hand side of -7. How do I write the solution now? The solution now requires the union symbol. Between -infinity and -7, union between 7 and infinity. This was not necessary with the first one. The first one was easy and nice. This one is not really that easy or that nice. Okay, so we have a few minutes. I'd like to at least practice one from each. Questions? Questions? Please, yes?
I know you said this, but I missed it.
That's fine. I wanna say it again. I'm sure if you missed it, other students missed it too.
Oh, so back to the end of the 1.6, where you did the word problem.
Oh.
Sorry.
No problem. See, I could have not done this with the board, right? You could have not asked me half an hour later, go back to the...
Can you say how you got 40? Yeah, that one.
Yes, for someone who is born in 1970, who is 0 years old in 1970, that person in 2010 will be 40 years old.
Okay, sorry.
That's why we discussed that. That's why I take notes when I read a problem. It's a very good question. That's why I take notes and I write what each variable means. So P is the percentage, blah, 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 and T is the number of years since 1970. Because then I will not know what to plug in. Is that okay?
Yeah.
Okay, so now other questions, please? Say it again.
Just using the graph.
Yes, of course. Of course.
For the steps for the radicals,
Yes.
you said eliminate the denominator and numerator.
For
you said
not,
you didn't
not
want
for
us to do
radicals, not for radicals, but for equations with a fractional exponent. So if I have x in parentheses and the exponent is 5, then I'm going to take the fifth root. But if the exponent is 2 over 5, I will first raise everything to the fifth power and then square, not at the same time.
Okay.
So if I have something like this, let's say x minus 3 to 2/5, first raise to the fifth power, and then eliminate this, and then square both sides. Two.
See, I was doing fine for 2.
If you do it in one step, for some problems, you will get the correct answer. But for others, like the second one we did, you will not, unless you remember the plus or minus. But then it may get confusing. When do you put plus or minus and when do you don't? But if you do it in these two steps, you will never make an error. Because here when you square, right? A square root I meant to write, of course. Sorry, I just in the middle I started answering your question. So square root. So then I take the square root, then you will know you have to put plus or minus.
Okay.
But if you raise both sides to 5/2, you may not know that you have to put this plus or minus.
Right. Okay.
So always remember, do this first, eliminate this first, and then eliminate this second.
So then it just becomes x minus 3 to the power 2.
Yes, but then when you take the square root, but I didn't write the right hand side. This is an equation. You
Yeah.
cannot do that. I can't say, don't forget what you want to say. I can't say I have $2 in my pocket, let me square it and see what I get.
Okay.
But if it's an equation, I can square both sides, or I can take both sides to the fifth power. Kayla?
So you're saying take 5 to the,
Raise to the fifth power
Raise
both
five.
sides, and then take the square root
so
to
raise
eliminate
2
it.
over 5 to the 5th power and raise x minus 3 to the 5th.
Okay?
Is that what you're saying?
Yep. So,
I think I messed that up.
that's okay. So my example was, did not have the right-hand side. So let me make up a right-hand side.
Oh,
Okay? So first I want to eliminate this by raising both sides to the fifth power. So I get x minus 3 to the second power equals 2 to the fifth, which is 32.
oh, and then
And now I take the square root to eliminate the numerator. And I will get x minus 3 equals plus or minus. This is 16 times 2, 4 the square root of 2. And this is 3 plus or minus 4 the square root of 2.
okay, I understand now.
If you, that's okay. I'd rather say it as many times as we need it. So if you do,
6 over 11 or something.
Yes.
Not always 2 over.
that's fine. We can talk about that. So if you do this at 5/2, you are eliminating the power in one step, right? So you get x minus 3 equals 2 to the fifth, 2 raised to the 5/2. But will you put plus or minus in there?
Can you tell us to?
Yeah, we remember.
So that's why this is not a useful method unless you memorize the formula. When this is odd and this is even, you don't put plus or minus. When this is odd and the other one is even, then you do. So I don't recommend that. Too much to remember. Right. So if you remove the denominator first, always as the first step, then you will always remember to put plus or minus, because this is from quadratics. Okay, so careful with that.
If it was 4 over 5, it would still be plus or minus.
If it's a 4 over, yeah. Because remember, we have, if we take the cube root of 8, right, we only have 2. But do I have two numbers that I can square to get 4? Yes. I can square 2 to get 4, and I can square negative 2 to get 4. But I cannot cube 2 and negative 2 to get 8. So when it comes to an odd power and real solutions, we only get one solution. I can't find two numbers that I cube to get 8. But I can, and I do have two numbers that I square to get 4, though. That's where the plus or minus is coming from. or are coming from. Okay, so let's look at an example of those problem, absolute value inequalities. So here's the first one, 66. Still on 203. 3, quantity x minus 1 plus 2, absolute value less than or equal to 20. Ready? Is this cleaned up? On the outside is, but not in the inside. So we can perform operations inside, it's just we cannot move stuff outside. There are some properties, but we don't study those properties in this class. So, but for now, I will just distribute and have 3x minus 3 and plus 2. And I will say 3x minus 1 in absolute value less than or equal to 20. So my question now to myself is, what do I do? Is this the first type that is nice and easy, I write it in a chain, elegant, or the other one where I have to completely separate two inequalities and solve? So that's our question. That's how we determine what to do next. I'm logged out and I need to take attendance, so I'm just logging myself back in. So, we don't have to guess. We just have to look and read. I'm asked to find numbers whose distance from 0 is less than or equal to 20. These numbers whose distance from 0 is less than or equal to 20. Less than or equal to 20. So how do I write? Where will they be found? Between what and what?
Negative 20.
Thank you. If we're looking for numbers between whose distance from 0 is 20 or less, they have to be found between negative 20 and 20. I know how to perform the operations now because this is a compound inequality. What is the first step?
Add on.
Of course. So that means negative 19 less than or equal to 3x less than or equal to 21. We're adding 1 to all three sides, of course. I add 1 on the left, I get negative 19. I add 1 in the middle, I get 3x. I add 1, yes?
If it's 3x plus 1, you still add the 1.
I have to clean it up. I have to clean up inside and
I know, like it won't change, you won't minus 1, like the sign, or it's always going to be positive.
if this is negative 10, I add 10. If this is positive 10, I subtract 10.
Okay, so that's what
I have to move it to the other side. When I move it, it changes its sign.
Equal sign.
Exactly, exactly. Exactly the same. Awesome, yes. And final step, it's not cleaned up. We divide by 3 all three sides. So negative 19 thirds less than or equal to x less than or equal to 7. And this is the solution. We do not have to use the union. We do not have to use anything. What you see is the actual solution.